All right. So to add fractions, we do need that common denominator. And I know you know how to do this, but I'm going to talk about it slightly differently. Using the language we were talking with yesterday, and yesterday the language was factor first. And so I'm going to do that, factor first. I'm going to factor these denominators. Well, I'm going to leave the 4. The 4 is okay. But I can break apart the 12. I could break apart the 12 into 4 times 3, right? So I broke it up into its factors. Good enough. And then we looked for the common denominator. The common denominator are all of the factors. Okay, the lowest common denominator is actually a multiple. We need each factor. They both have a 4 in common. This one also has a 3, which means over here also needs a 3. And of course, if we multiply the bottom, we have to multiply the top. Why? It reduces to 1. Very good. 3 over 3 reduces to 1. So by multiplying top and bottom, it's just multiplying by 1. We haven't changed the value of the fraction. Really important we understand that. I do calculus for fun at home. I know. I'm sorry. And I'm constantly reminding myself, what can I do? What can I multiply by so that I'm not changing the expression? And it's always, multiplying by something like that. 17 twelfths. Okay.
That's 14.
Oh, sure it is. I don't know why I got that. Thank you. Thank God it's fast. Oh, and then what? It reduces, yeah. To 7. Thank you. Okay, good. All right, so we're doing the same thing. It's just polynomials. So you're like, say what? Example 1, perform the indicated operations. So what we really want to remember about, and I'll show you this one of these days. What we really want to remember is that polynomials act the same way that numbers do. So whatever we can do with plain old numbers, we can also do with polynomials. And that's kind of interesting. And I'll show you something kind of cool later. But until then, we'll just learn some skills. 3x over 4y times 8y squared over 9x. It's hot in here.
Well, thank you.
Alright, sorry about that. Okay, so there are a couple of things we can do. I'm interested in what you guys want to do first with this rational fractional expression. Multiply across? Okay, we could do that. Is there another option? Oh, cross reduce. All right, cross reduce. Okay. You certainly can multiply across. That's totally fine. Either of those methods is going to be perfect. We always just want to make sure we're done reducing at the end. So what can we cross reduce here? Okay, so I can reduce the x on top divided by x on bottom. Those reduce to 1s. Also the number 3 goes into 3 one time and 3 goes into 9 3 times. And then I can reduce my 8 and my 4. 4 goes into 4 one time and 4 goes into 8 2 times. And the y's. Y squared on top and a y on bottom. Leaves a y on top. Yeah. Good. Extra y on top. It gets kind of messy, I guess. 1 times 2 times y. And on the top, and then on the bottom, 1 times 1 times 3 times 1. 3. That's all. And always, can I reduce further? No, we're good. Okay. Now, you have a couple of those, but most of them are like this, where you have binomials and trinomials. What do we need to do first? Keep, change, flip. Okay, so we are going to multiply by the reciprocal. But we're also, what do we need to do with these polynomials? Factor first. Factor first. You cannot reduce unless we're in bubble form, right? We talked about this yesterday. So if you had like x plus 3 over x minus 2, can you just cross off the x's? No, you cannot. It doesn't work that way. I put the numbers yesterday. Remember, we proved it with numbers. That is a bad idea. Things have to be rewritten as a product. So when things are multiplied, then we can reduce. So let's think about that. I'm going to look at this first polynomial here. What do you notice about that one? Take out a 3. Greatest common factor of 3. So I'm going to take out the 3. What's left behind if I take out a 3 from there? Good. Does that factor?
Yeah. Oh, no.
Yeah, it's not difference of squares. Okay, good. All right. I'm going to do the same thing in the bottom here. 3a. Okay, so there's another GCF of 3a. And what does that leave behind if we take that out? A minus 5. Very good. I am going to multiply by the reciprocal. So I'm going to change my sign to multiply. And I've got to flip my fraction. So I have what's going to be this, a squared minus 3a minus 10. That's going to be on top because I have to flip my fraction.
Does it flip their sign as well?
No. So a squared minus 3a minus 10. How does that double bubble? A times a is a squared. What times what is negative 10? Negative 5, positive 2. How do you know you did it right? Check the rainbow. Very good. Okay. And then what will be on the denominator? A to the 4th minus 16. What does that do? All right, so a squared times a squared is a to the 4th, and then plus 4 and minus 4. Are we done? No.
No, you could factor that one.
Yeah, very, very good. Okay. So that a squared minus 4, I'm just going to cross that out and smush it in. How does that factor? Very good. A minus 2, a plus 2. Bubbles. Once you get them in bubble form, everything now is connected by multiplication. And since everything is multiplied, now we can pop those bubbles or reduce. Okay? I like to think about it as popping bubbles because I have a fun visual in my head of that. Like, pop, pop. Okay. These are the hind ones when they reduce. Because it's a minus 5 divided by a minus 5, which is 1. What else goes away? Yes, of course. A plus 2 on the top and a plus 2 on the bottom and a squared plus 4 and the a squared plus 4 and 3 on top, 3 on bottom, reduced to 1s as well. Awesome. So we got 1 times 1 times 1 times, 1 over.
A, and then A.
Very good. We have an A there out in front and the A minus 2. Very good. Okay, so factor first is the key. And once you factor, then you can pop all those bubbles and go from there. Do you have questions on that one? Good. There it is. Just these, though, I think. Oh, we do have more. We'll see. We maybe don't have to do all of them. So adding and subtracting fractions, you must have a common denominator. And so these are variations on adding and subtracting fractions. We have x plus 3 over 10 plus 2x plus 1 over 15 minus the entire x minus 2 over 18. All right. Those numbers are huge to me, like a number bigger than like 5. It's too big. So what I'm going to do is break these apart a little bit and just see what their factors are made of. So I can rewrite 10 as what? 2 times 5. And 15 is 5 times 3. And 18 is 6 times 3. And 6 breaks apart into 2 times 3. So 2 times 3 times 3? Yeah? Is that right? Yeah. Okay. Yes. 9 times 2 is 18. Got it. Okay. And so when we try to get a common denominator, we just want to see what matches and make sure we still have everything on each denominator. I know that sounds weird, but watch what I do. First of all, I notice that I have some fractions that have a 5 already. Which one's missing a 5?
18.
The last one, yeah. So I'm going to multiply that by 5 on top and bottom, because everything must have all the same components. And then I notice that here is a 2. That's fantastic. And here's another 2. Who's missing the 2? Yeah, so I got to put a 2 on that one. So I'm going to multiply that top and bottom by 2. I'm just going to smush it on. I encourage you to smush it. Smush it. And then, let's see, what else we have here? We've got 3s. We've got a few 3s, right? We need all of them. This one has 2 of them. So this one's got 1. What does he need? Another one. So we got to multiply that by 3 as well. Weird, right? Let's play it. Go with me for it. All right. So, and then over here, what does he need? 2 3s, right? 3 times 3, or 6, or 9 rather. Oh God. Okay. Thank God it's Friday. Okay. So now when you look at those denominators, are they all made up of the same factors? Yeah, they are. They both have 2 3s, a 2 and a 5. 3 3 2 and 5. All right. We have a common denominator. Now the question is, what is it? 9 times 10, 90. See, that number was way too big. I was never going to get there. But I can break it down in factors and just make sure I've got all the little factors. And that's your lowest common denominator. That's really what lowest common denominator is. Okay? So now that I have a common denominator where they're made up of all the same parts, now I can think about my numerator. The numerator is the thing where all the magic happens. This is 9 times the quantity x plus 3. I am going to distribute, but I'm going to write it out first to clean it up. Here I have 2 times 3, or 6. So it's going to be plus 6 times the 2x plus 1. And my last numerator has a negative out in front, and I have to multiply by 5. So that's going to be a negative 5 times the x minus 2. Please, ladies and gentlemen, the negatives cause all of the algebra problems. Why? Because you have to distribute it. And everyone always goes minus x minus 2. But you can't do that. You've got to distribute your negative. Okay, so we've cleaned it up. It's beautiful. We need to distribute and combine like terms. So what do we get when we distribute?
12x plus 6.
Plus 10. The most common mistake, yes. All right, very good. And then we can just combine our like terms. So let me think here. I have a 9x and a 12x and a minus 5x, and that would be 16x's. Very good. And again, numbers that are bigger than 7, I just, 27, positive 6, positive 10. 43? Okay. All right. And then over our common denominator of 90. Can I reduce this fraction at all? No. What? Can you reduce by 2? No, why not? 43 odd.
Oh, yeah.
But good. So we're good. Can you reduce by 3?
No.
No, because 4 plus 3 is 7. 7 is not divisible by 3, so that does not come out. Very good. All right, very, very good. Let's look at letter B here. Again, when I think about, we just need to make our denominators common. We really want it to be the lowest common denominator. And of course, you can do the whole multiply this fraction by the 9xy and multiply this fraction by the 6x squared. You can do that, but it's not the lowest common denominator. So you will have to reduce once you do that. So again, if I think in terms of factors, I'm thinking, again, you probably have a shortcut you can do. 6 is 2 times 3, and x means what? X times x. And you can probably just see that, and maybe you can see it's great. 3 times 3 is 9 times x times y. Those are the denominators all factored out in their prime factors, okay? And again, I'm hoping you'll see the shortcut when you go to do the work. But let's look at what they have in common. What matches? 3x. Don't they both have a 3x? Okay. They both have a 3x. This one has a 2. What does the right side need? It needs a 2 on top and bottom. So we've got the purple factor of 2. And then we have, what else do we need? Okay, we got a y on the right. We need a y on the left. So I'm going to multiply that y on the left fraction as well. All right, we're almost there. Another 3. We got a 3 on the right. We need a 3 on the left. Anything else?
Doesn't the right side need another x?
It does. Very good. That right side needs another x. I got a little squishy x right there. Yeah, I know. It's hard to see sometimes. But again, this is me modeling what you could do. Maybe you can see it. Like, what is the lowest common multiple of 6 and 9? 18. So what did you need to multiply to get there? Okay. Yeah, 3 and 2. And which is what we did. There's the 3 and there's the 2. And then we have an x squared. This one needs another x. We have a y. This one needs a y. So, yes, there are shortcuts to this. So what is the lowest common denominator? 18. So 3 times 3 is 9, times 2 is 18. 3 times 3 is 9, times 2 is 18. Okay, and then x to the second, y. So that's our lowest common denominator. And maybe you saw that. That's great. On my numerator here, 3 times 1 times y is 3y minus 10x. All right, can we reduce it all?
No.
Good so far? Okay. All right. These are the last 2. 3 over y plus 6 over y squared minus 2y. What's the difference here with C and D compared to A and B? Addition and subtraction in the denominator. It's not a monomial. What does monomial mean? One term. Here we have binomial, binomials, okay? Sometimes trinomials. Anytime you've got that addition and subtraction, you must factor first, which is what we were doing before. All right, so looking at this, I can't factor y, but I can factor this denominator. What can I do with our denominator here? A y, greatest common factor of y. What's left behind? Y minus 2, very good. All right, what do they have in common? They both have a y. What do we need? See how that works now? We need a y minus 2 to match on that first fraction. Now they both have the lowest common denominator, the same common factors. So I have a common denominator of y times y minus 2. The nice thing is you can leave it in bubble form. But we do have to combine my numerator. Should I write 3 times the quantity y minus 2, or can I just distribute? Distribute. Yeah. You can just distribute 3y minus 6 plus the 6, and what happens with that? The 6's add to be 0, so we have 3y over y times y minus 2. Can we reduce?
Yes.
Yes, this is 3 times y. So y divided by y reduces to 1s. And we're left with 3 over y minus 2. Okay. That's a good one. All right, and letter D, last one. Again, what do we need to do with our denominators? Factor if we can. Factor if we can. All right, can I factor the first one? No, it's its own bubble. It's a prime factor like 5. Here we have another prime factor. What about this last one? Yeah, x plus 1, x minus 1. So I like to do the little cheater's method here. It's just to cross it out and write below. Okay. All right, what's in common? Yeah, we've got, all right, here's an x plus 1. Here's an x plus 1. What does this one need? X plus 1 on top and bottom. All right, so now they've each got a purple factor. And then what else does it need? Yeah, we've got an x minus 1. Here's an x minus 1. This one needs an x minus 1 on top and bottom. All right, this one I am going to write carefully. So what's my common denominator? Good. X plus 1, x minus 1. My numerator, I am going to write it nicely. What's my second fraction? What should I write for this? Here. -2 times the x minus 1. Very good. And then the last one is just the plus x plus 3. So again, because of the negative, did I goof? Because I did step in my head. And yeah, thank you. Good catch. Again, those negatives are really tricky. So remember, it's attached to whatever's on top, but if there's 2 things on top, you must distribute that negative. So be really, really careful. All right, I'm going to go ahead and distribute. What do we get when we distribute? And then 2x plus 2. Whoops. Plus an x plus 3. I'm distributing. All right. Let's see. We have a positive 3x and a negative 2x and a positive x, which gives me 2 x's. And I have a positive 3 and a positive 2 and a positive 3. 8 It must be Friday. All right, can we reduce? You can take out, we could take out a 2. Yeah, there is a GCF on top. I would say I recommend doing that. If there's a GCF, take it out. Is it wrong to leave it in? No, it's not. These are equivalent. They are exactly equal to one another. Either of these answers is great. But in this form, I know so much information about the graph that you guys will learn about later. But when we have everything written in bubbles, I know the most about the function. All right, and so this is always going to be the goal in algebra. Okay? Do you guys have any questions for me? Right on, it's quick work. Please, ladies and gentlemen, write the original problem. Write the original problem.